Between 1930 and 1941, Soviet military planners calculated they would need to arm millions of men in the event of a major European war, a figure derived from the Red Army's mobilization capacity and territorial defense requirements across thousands of kilometers of borders. The standard infantry rifle inherited from the Tsarist-era, the Model 1891 Mosin-Nagant, presented a manufacturing bottleneck due to its lengthy 48.5-inch overall dimension and labor-intensive production specifications from the Imperial Tula and Ijevsk arsenals. In 1930, Soviet Ordnance Committees authorized a modernized variant designated the M91/30, standardizing measurement specifications to the metric system and eliminating the Arshin-based dimensions that required conversion tables at factory level. If you're interested in how wars are actually decided by logistics, math, weapons, and doctrine, subscribe now. Turn on notifications and stay tuned for more in-depth World War II analysis. Let's continue. The M91/30 retained the 4-groove right-hand twist rifling and the 7.62 by 54mm AR cartridge, but simplified receiver production by transitioning hexagonal receivers to cylindrical variants, significantly reducing machining time per unit at the Ijevsk facility. Stalin's 5-year plans allocated massive resources to expand rifle production capacity, constructing new production lines at Tula Arsenal and establishing duplicate tooling at the Ijevsk Mechanical Works. Each rifle required roughly 10 kilograms of raw steel when accounting for machining waste, and the industrial scale needed to arm the Red Army consumed an enormous share of Soviet small-arms steel allocation across the 11-year industrialization period. The fingers of a rifle inspector at Ijevsk close around the finished stock, wood and steel, manufactured weight consistent across millions of units. This rimmed round, inherited from the original Model 1891 design, demanded sufficient barrel length to achieve muzzle velocity standards while the rifle remained manageable for an average conscript. The bolt cycles with 3 movements: lift, pull, push, actuating a manual action that feeds from a fixed internal magazine holding 5 rounds. No detachable box, no spring-loaded follower assembly requiring precision metalwork. Sheet metal formed the magazine floor plate. The bolt itself consisted of 7 major components compared to the semi-automatic VT-40's 42 parts, each requiring different machining operations and tolerances measured in hundredths of millimeters. The receiver came in 3 documented variants: round low wall, round high wall, and hexagonal. Yet all accepted interchangeable bolts without individual fitting, a manufacturing achievement enabling field armories to swap damaged components without specialized gauging equipment. Inside the barrel, 4 grooves spiraled rightward, cut deep enough to maintain accuracy through thousands of rounds before measurable degradation occurred. The cleaning rod became the primary maintenance tool, requiring daily bore cleaning in field conditions. Regulations mandated complete field stripping after sustained use, a procedure trainable to conscripts in 20 minutes, using no tools beyond the rifle's own components. The wooden stock could be replaced by 2 soldiers using basic hand tools. Warping occurred at extreme cold, splitting the wood longitudinally, but the weapon remained serviceable. Every simplification translated directly into production capacity. Fewer operations meant faster manufacturing. Interchangeable parts meant distributed maintenance. Robust tolerances meant conscript armories could service weapons without rejecting components for minor imperfections. On June 22, 1941, Operation Barbarossa shattered the Soviet frontier with 3.8 million Axis troops, catching Red Army forces mid-reorganization and triggering the largest distribution of small arms in military history. The Mosin-Nagant M91/30, stockpiled in quantities of millions of rifles across Western arsenals, became the standard weapon for hastily mobilized conscripts streaming toward the front. Factory records from Tula show production accelerated to thousands of rifles daily by July 1941, with crates loaded onto trains before finishing inspections could be completed. The Wehrmacht's opening weeks exposed critical gaps between Soviet doctrine and reality. German infantry divisions, equipped with Mauser Kar 98K rifles and extensive combined arms training, engaged Soviet rifle divisions where large numbers of conscripts had received fewer than 10 days of weapons instruction. The M91/30's length, designed for imperial-era close-order drill, proved cumbersome in mechanized warfare. Soviet riflemen attempting to deploy from trucks or trenches struggled with the extended profile, while German assault teams maneuvered with carbines measuring 43.6 inches. Encirclement operations at Minsk in early July captured 290,000 Soviet troops and revealed ammunition logistics failures. The 7.62 x 54 R cartridge, incompatible with any captured German weapons, forced retreating Soviet units to abandon M91/30 rifles when supply lines collapsed. German after-action reports from Army Group Center documented recovering vast quantities of Soviet rifles from the Bialystok pocket alone. The rifle's mechanical performance under stress began at Smolensk in August 1941, where temperatures reached 35 degrees Celsius and generated dust conditions that infiltrated every weapon system. The M91/30's manual bolt action, requiring a complete cycle time of roughly 2 seconds under ideal conditions, slowed considerably when mechanisms became fouled with Ukrainian soil. Soviet training doctrine emphasized the leaf rear sight, graduated from 100 to 2,000 meters, but engagement distances in defensive fighting rarely exceeded 300 meters, rendering the optimistic range graduations irrelevant. On December 5, 1941, temperatures dropped to -38 degrees Celsius along the Klin axis. Red Army units began the Moscow counteroffensive, with rifle maintenance personnel recording immediate contact freeze. Bare skin adhering to M91/30 receiver steel within seconds of exposure. The weapon's laminated birch stock, saturated with linseed oil at arsenal finishing stations, contracted in the extreme cold, loosening barrel bands, but preventing the catastrophic splitting observed in walnut-stocked captured carabiner 98K rifles. The Mosin's bolt sleeve, machined from single-piece forged steel with generous clearances, maintained cycling function at -40 degrees, while German Mauser extractors, heat-treated to higher Rockwell hardness for precision fit, shattered under identical conditions. Soviet after-action reports from First Shock Army documented remarkably low M91/30 stoppage rates during the Kalinin offensive, attributed primarily to ammunition primer failures rather than mechanical defects. The rifle's crude machining tolerances, criticized at inspection stations in September, now functioned as thermal expansion buffers. The slop in bolt raceway dimensions absorbed contraction stress without binding. Barrel life data from Rifle Division armorer logs indicated M91/30 tubes reaching thousands of rounds before accuracy degradation beyond combat standards, exceeding peacetime testing expectations. The 5-shot internal magazine, stamped from sheet steel and spot-welded, fed reliably through mud-ice slurry conditions that choked the more sophisticated staggered column magazines of captured MP-40 submachine guns. German intelligence assessments from Army Group Center noted Soviet rifle mechanical reliability with alarm, contrasting significantly higher Wehrmacht small arms failure rates during the same operational period. The Mosin-Nagant M91/30 sniper variant emerged from Tula and Izhevsk arsenals beginning in 1932, fitted with magnification scopes mounted to clear the bolt handle. By 1940, the PU scope replaced earlier models, featuring a simpler 3.5 times magnification design mounted directly above the bore centerline, requiring bent bolt handles on converted rifles. Soviet ordnance specifications demanded sniper rifles achieve tight zeroing tolerance, transforming select rifles from standard infantry weapons into precision instruments through careful barrel selection and scope mounting. At Stalingrad, from August 1942 through February 1943, destruction created engagement ranges between 200 and 800 meters across ruined factories and apartment blocks. Vasily Zaitsev of the 1047th Rifle Regiment, 284th Rifle Division, employed his Pu-equipped 91/30 from positions inside the Lazur chemical plant, and Mamayev Kurgan, recording approximately 225 confirmed eliminations during the battle. The Pu scope's graduated reticle compensated for bullet drop, enabling first-round hits against German machine gun crews and forward observers directing artillery. Sniper training schools established pre-war at Moscow and Podolsk expanded massively during wartime, producing tens of thousands of qualified marksmen by late 1942, with dedicated courses teaching range estimation using the Pu scope's stadiometric range-finding method. Female snipers, including Lyudmila Pavlichenko, credited with 309 eliminations, and Rosa Shanina with 59, demonstrated the program's systematic approach to precision fire. The barrel provided sufficient velocity, approximately 2,800 feet per second at muzzle, to maintain lethal energy beyond 800 meters, though wind deflection at that distance required constant environmental assessment. Hundreds of thousands of sniper-configured rifles were produced from 1942 through 1945. Each rifle underwent individual test firing before receiving scope mounting brackets, with rejected barrels returned to standard infantry configuration. The combination of mass production manufacturing tolerances and selective quality control created an asymmetric advantage in urban environments where trained marksmen equipped with inexpensive scopes neutralized targets that would otherwise require costly artillery salvos. Between 1941 and 1945, Soviet arsenals manufactured approximately 17.4 million Mosin-Nagant rifles across all variants, roughly double the output of German Mauser production during the same period. This numerical superiority extended to specialized precision variants, with Soviet factories fitting hundreds of thousands of optical instruments to rifles during wartime, dwarfing Wehrmacht sniper rifle output. The mathematics of industrial capacity translated directly into battlefield mathematics. Soviet forces advanced 1,800 kilometers westward from Stalingrad to Berlin while sustaining catastrophic losses. Each kilometer gained measured in lives. The weapon's service life extended 5 decades beyond May 1945. Chinese Type 53 variants saw action during the Korean War, where extreme cold again tested the rifle's reliability. Vietnamese forces chambered hundreds of thousands of Mosin-Nagants during operations from 1965 through 1975, the optical instruments proving effective in jungle canopy engagements. Afghan Mujahideen fighters wielded Soviet-supplied precision variants against Soviet troops during the 1979 to 1989 conflict, creating the strategic paradox of a weapon system engaging its own manufacturers. Syrian opposition forces documented use of scoped variants in 2015 urban combat, the same Pu scope optics still gathering light in Aleppo's rubble as they had in Stalingrad's ruins 70 years before. The calculations Soviet planners made in the 1930s, arming millions of men across vast borders, proved conservative. By 1945, over 17 million rifles had armed forces that pushed those borders 1,800 kilometers westward. The manufacturing bottleneck of the Tsarist-era transformed into an industrial avalanche that buried the Wehrmacht under the sheer weight of production. If you enjoyed this story, hit subscribe for more. World War II historical deep dives every week. Thanks for watching.